So we're at the point now where we're discussing the ammeter and how the ammeter gets connected into the circuit, and the notes, just like the voltage meter part in the textbook, show that we can move the ammeter around the circuit. We can put it halfway through this conducting wire, we can put it in the other conducting wire, or we can put it close perhaps to the source itself. And I've asked the question to the class, if we do move the current meter around the circuit, what will happen on the current meter? And some people say it'll give a higher current when it's closer to the source and a lower current when it's closer to the load. Some people say no, it won't make any difference at all. It'll be the same current no matter where it is in the circuit. So I'm going to ask Wade to go ahead and we'll do a bit of a test to test this out. I'll get Wade to put the meter connected as a current meter at the voltage source, and then we'll note the current, and then later we'll move the current meter down the circuit to the load end, and we'll measure the current again, and we'll compare those two currents and see if they're in fact the same. So Wade's just hooking that meter up now. We've got the meter connected as a DC milliamp meter to 200 milliamps, and Wade knows to connect the most positive side of the meter to the most positive side of the circuit, and we're measuring 167.7 milliamps, and that's with 17.2 volts on the supply. So again, 167 point, it's a bit dodgy there, 167.5 say, milliamps. Alright, let's turn that off and we'll move it to the other end. Okay, now we're connecting the ammeter to the other end of the circuit. No, Wade, you have to make the circuit, you need to move this red one here to the most positive side of the circuit, which is this. Good. And then you can put the black one into there, make sure they're both firm. We should be measuring more current. We're measuring 163, 164 milliamps. We were looking for 167.5. Where's the extra current gone? So Mitch, I thought we said that the current's going to be the same at every point in the circuit.
Should be.
What's happened? It should be. Dodgy meter, perhaps. Alright, let's critique this and find out where we've gone wrong. We repeat the experiment because we did have that anomaly before, and this time we've got 170 milliamps at the hot end of the circuit.
And it's really important to remember that when you're measuring current, you must do so by breaking the circuit.
That is in line with the supply and the wire, and then I'll turn that off and I'll move the current meter down towards the, and we move down to the end of the wire, and now Wade, what I've done, I've captured that hot terminal of the ammeter and I've screwed it down to make sure I've got a very low resistance connection here now, and I'll hold the black terminal on here, 170 milliamps. So the fact is that we're supposed to have the same current. The fact is we have the same current at any point in a series circuit. The fact that we had the different current there before showed me that we must have had a dodgy connection at this end of the circuit, probably some resistance in the wire where we were holding the ammeter into the circuit.